Hello everyone, it's the Math Educator and we're back for some more knowledge. Now I know it's only my second episode, but I figured we want to do something big today. We're going to divide by zero. Now I know there's all kinds of risks involved in that and it might collapse the universe, but I think that it's worth it if we gain some deeper understanding into mathematics. And if I do destroy the universe, I just want to say I'm sorry. That's not what I wanted. I don't want to destroy the universe, but I think it's important to try in order to see what happens. Okay? So going back now. 1 divided by 0. All right, everyone good? We're all still here? All right, okay. So, divided by 0. Well, everyone says it can't be done, but obviously I just did it. So, what's up with that? Why do all the memes and stuff say, oh, it'll collapse the universe? Well, while it's true that I can technically divide by 0, there are consequences to doing so. What are some of those consequences? Let's see. I want to talk a little bit about what consequences means in math. Math is all about systems that are internally logical. So you don't necessarily have to doing something in particular is not necessarily wrong, it's just that there are certain things that come about when you do it. For example, in our early days of mathematics, when we're first learning, it doesn't make sense for us to do something like this problem here. Normally we think, if I have a group of things, and I take away from that group, I can't take more than what was originally there. So taking away 13 from 9 doesn't make any sense. Well, then we learn in algebra that, we learn about these things called negative numbers. And so once we learn about those, we can subtract numbers that are bigger from numbers that are not as big. So what all that means is that allowing for this sort of subtraction has a consequence. You have to be able to accept negative numbers. So instead of this little question mark here, we have negative 4. If I start with 9 and take away 13, then I've taken away more than I originally had, and then 4 more. So there's that. Another example is something like this problem here. We also know from algebra that if I multiply 2 positive numbers, I get a positive number. And if I multiply 2 negative numbers, I also get a positive number. And so something like this shouldn't make any sense, because if I have the same number multiplied with itself, I should always get a positive number. Well, then we have things like the imaginary numbers, our I, the square root of -1. So this is a consequence of allowing this sort of thing to happen by essentially taking square roots of negative numbers. For example, in this case, x is simply the square root of -4, which that isn't a number that's in our traditional number system, or the real number system. So we expand it to include numbers that will fit this. And that's where the so-called complex numbers come from. This is simply x is equal to the square root of 4 times our little imaginary unit, I. And so we get x equals 2i. So in both cases, our idea of numbers expanded because we took this step outside of the norms. But what does this look like for division by 0? Well, it doesn't expand our number system, quite the opposite. So let's say for a moment that we can divide by 0. That means that one of the numbers in our system should be this, the quotient of 1 and 0. Well, this can lead to a bit of a sticky problem, because what is this equal to? Well, there's two answers, and they're both, in a way, equally valid. Normally, I know that anything anything multiplied by 0 is 0. Multiplication is like, adding groups. If I have 0 groups of something, I don't have anything, then logically I should have nothing. I should have 0. So this has to be 0. But on the other hand, I know that if I multiply a number with its reciprocal, I should always get 1. We have 0, and we have 1 divided by 0. With any other number, this would be the reciprocal of 0. So logically, this number should also be 1. So that leaves us with the conclusion that 1 is equal to 0. Now that could be a bit of a tricky problem, but it's actually even worse than that. So let's pick any real number, any arbitrary real number. Let's just call it r, okay? So if I have r, now I know that if I multiply r times 1, I'll just get r again. So r is the same as r times 1. But because I divided by 0, I now know that 1 and 0 are the same number. So this should be the same as r times 0. But I also know that 0 times any number is 0, which means that this has to be equal to 0. So if I look down this chain, I realize that any real number has to be equal to 0. That's also a bit of a problem. My entire real number system, all real numbers, the symbol for all real numbers, is just, the set of real numbers is just 0. There's no 1, there's no 2, there's no pi. They don't exist. Everything is just 0. Now here's the really interesting part. This isn't necessarily a problem. Now, in examples of, there's all kinds of different number systems. One that we talk about in group theory, we have a group with only one unit in it, with only one element. And this is fine, it's just not very interesting. So having a number system where the only number is 0, mathematically it isn't an issue. But the problem is that it's not useful. It's basically like, we use numbers to help us out in our everyday lives, to talk about real, discernible things. It would be like, and so if we only have 0, then it's like there's nothing we can do with that. We can't use that for anything. It'd be like, if I had, instead of 10 fingers, I just had 0 fingers. Like that. So it's not really a problem, it's just that it's not useful to us. So we don't want this to be the case, and so what that means is that we don't allow division by 0 in our traditional number system. Thanks.